And do you see slides? Could somebody confirm? Okay, thank you very much. Okay, so the subject for today is multi-thread programming in Java. Okay, so now we finished with some basic ideas of Java, just a kind of the short introduction to object-oriented programming. However, maybe it was a short introduction to Java basic ideas, and now we'll switch into multi-threading. So I assume that most of you are not familiar with multi-threading, okay? On the previous lecture, I was assuming that you have background of object-oriented programming. Maybe you did not have a background on Java as the language, but the ideas were quite the same as in C++, C#, and that kind of languages. Of course, multi-threading exists also in other languages. So there are small differences in implementations, but let me start from some general ideas, the reasons why really we have to work with multi-threading in Java. On the other hand, Java was one of the first popular language that has built-in multi-threaded elements, okay, from the beginning. Okay. You could and you will really program in C++ with threads and processes. It will be the labs with Darius later, but it was added to C or C++, or you will use threads from the operating system, okay? But Java was multi-thread language from the beginning, because 90s, when the Java was born, was time that multi-threading became important. Okay, so what is important is the first statement, that it is not easy task. Okay, so writing a correct and efficient multi-threaded code is, unfortunately for you, because it will be your task, much more difficult than for a single thread. Okay, so-called sequential code. Okay, so if you don't have to play with threading, stay with sequential, if possible. But very often it is impossible, and it is impossible because you will find such instruction during the lab. What's the reason? The reason is the speed. Oh, the reason is the speed. Okay, so there are two reasons. So when the PC was born at the late 70s, beginning of 80s, so the desktop computers became available and popular. Usually about twice the new version of processor was usually twice as fast as the previous one. So each 2 or 3 years, we have twice faster processors with faster CPU clock. Okay, it was the idea, but it stopped. Okay, there are different reasons why it stops. Okay, okay, there are small changes. Still, the newer processor is slightly, but not has slightly faster CPU clock, but it is we are now using other approaches to speed up computers. Okay, the problem is mostly the heat. One of the problem. The other problem is the physics. Okay, because when you increase the clock, so we are now approaching the area of quantum computing, really, quantum effects, because when you look at the, we have several gigahertz. Okay, so the length of elements, okay, and the speed of clock causes that now it's hard to work to develop it, and also cost of memory access becomes higher, because if the processor is faster, the CPU clock is faster, so the memory has to be faster, okay? So what was the solution? To have still that idea to have more computational power each year, okay? So we switch into multi-core system, okay? And probably, or not probably, I'm almost sure that maybe there are a small exception of you have mobiles in your pockets and just look in the documentation for that mobile, for the specification, and you will notice that there are 8, even sometimes 12, 16 cores available there. Okay, so we have now multi-core programming to achieve more speed, but to achieve it, you have to use multi-thread program. Okay, so it was like that in the past. Okay, so it was called Moore law. Okay, so computers were faster. However, it was nice from the point of view of programmers, since the code was still the same. Okay, we have newer programs, but the idea of coding was the same. But now, when we have still more or less the same speed up, but achieved in different way, not by having more powerful processors, but having more than one processor, okay, or more than one core, okay, because processor is the name of the chip. So in one chip, you could have several cores inside. Okay, now you have the speed up, but it's not so simple because your code has to take in consideration the fact that there are more than one core. So really, your code has to be rewritten. So what is the clever idea? If it is possible nowadays, use multi-threading approaches from the beginning, because this is our future. More cores, okay? So if we will use the same code as it was developed before that idea of multi-cores and run on the newer computer, it will use only 1/8 of its power. So there will be no speed up. Okay, so now I hope you are aware of two facts: that multi-threading allows us to consume the power of our modern computers, and that it is not easy task. Okay, it's not so simple. And this is my aim really on the lecture and the lab, to show you the problems and how to solve them. So at first you have to notice the difference of the one thread and multi-thread program. So let's look in that picture. So in a case of one thread control, show where is the code. Okay. So what is object-oriented programming? Object-oriented programming is calling methods of one object from the other object. Okay. So always we are in a place, given state, and we are changing it during the time. Okay. But in a case of parallel or concurrent computation, okay, there is an important difference, but and I will try to define what does in parallel and concurrent computation slightly later. But what's the problem? That at a given moment of time, each thread is in a different place of the code. Okay, so it could be seen as we have a set of single thread programs, and they are doing different things. So it's not so difficult, but the difficulty comes from the problem of collisions. And we'll really spend whole the next lecture, and I will try to show you how to solve that problem. Okay, so we know that idea of parallel processing for our everyday life. Okay, you can go to the any market nearby, okay? And very often there are more than one counter, okay? So, or even it's like that there's one counter, and if the staff will notice that the queue becomes longer, okay, I was today morning in a nearby shop, okay, and the queue becomes longer, so the next person came to the next counter, and now the queue became shorter and shorter because we have a parallel processing of customers. Okay, so it's more or less the same idea. Okay, but it requires organization and it requires features. Parallelism and concurrency. Okay, they could be achieved, or they are achieved in many languages by multi-thread programming, and they are achieved here, I mean, in Java by multi-thread programming. But so we have one solution to two slightly or totally different problems. Okay, so that's why they are shown here. So I hope that after that slide, after my lecture, you will not confuse these two concepts. They are similar in that sense that in many languages we are using the same features, the same techniques to solve these totally different problems. Okay. So one of the problem, and the problem mentioned by me before, is the problem of parallelism. Okay, so we use extra resources, so extra CPUs, extra cores available in our computers to solve a problem faster. Okay, so we have to do something, and we are really dividing the task into smaller tasks, and we are trying to run them in parallel. Okay, and the second problem, totally different, is the problem of correctly and efficient manage of access to shared resources. Okay? A lot of resources has to be shared in code, and they are slow in that sense that when you access it, okay, there is a given amount of time needed to play with it. Okay? CPUs are quite fast compared, for example, with files, internet connections, that kind of stuff. Okay, so thread. Okay, and really parallels all, and many other languages we are using exactly the same trick to solve slightly or totally different problems. Okay, it will become even more sophisticated since that in parallel computation we also from time to time need an access to shared resources. Okay, so very often in parallels we have to deal with concurrency problems, but concurrency as it is also exists on a single thread computer. Okay, so that things are similar, especially because in parallels we have elements of concurrency also, but they are slightly different problems. So connected because we are using more or less the same tricks. Okay, and they are connected because in most cases parallelism is connected with concurrency, but concurrency could exist without parallelism. Okay, so even in ancient time of one threaded computer, one core computers, okay, multi-threading was used mostly, of course, to solve the problem of concurrency, because it was not solving the problem of parallelism. Because if you have one core, so switching your code into two sub-elements will not speed up the result. Okay, so be aware of that these ideas are connected, but are not the same. Okay? So we'll start with parallelism. okay, and then switch into concurrency. Small off topic is that threads are not the only solution to that problem. Okay, Darius will talk with you about operating system and processes. Okay, and very often operating systems are using processes to solve the problem. Also nowadays we have techniques based on asynchronous programming that originates from concurrency, but also allow us to play with parallels. But now we'll talk about threads, okay, and we'll start with parallels. Okay, so this is not the only solution threads to the problem. There are other tricks used in computer world, and even there are some languages just oriented for parallel computers that has fast threads, etc., etc. But we talk about Java. Okay, however, threads in other languages are more or less similar. This is a quite general idea, and today it is supported by operating system, and even the CPUs are designed to be efficient to play with threads. But threads are not only used for parallelism, but also for concurrence. Okay, so different words, but maybe it will become slightly clear. Okay, so now I'm not talking about Java at all, okay, because threads exist outside the Java world. Okay, it exists nowadays in almost all languages. Okay, so just assume a code that you can notice here, like, okay, it is similar to Java, to whatever, okay, it does not matter, it's a pseudocode, okay, and the problem is to sum some elements in the array, okay, so we have the array and we want to sum elements. Using, if the sum range will be run in parallel somehow, okay, I will show you slightly later how to do it in Java, then there is a big chance that if we will divide the sum, okay, so you have to sum a huge array, just imagine 1 million of elements. So you can do it traditionally, summing, so going through the loop, adding, okay, and the solution, which is pseudo-coded here, it's not formal code, okay. The idea is divide the task into 4 smaller subtasks. So the idea inside that red loop is to divide the task into smaller tasks, okay, 4 tasks. Try to run in parallel somehow, okay. So I will show you slightly later how to run something in parallel in Java. But at first, you have to understand how to do it and what is the reason why we are doing it. Okay, so this is the example why, not how, why we are doing it. Okay, and get results from each of these subtasks and then sum up elements. Okay, so if the n will be huge, okay, if the size of the array will be really huge, okay, then we can go to roughly 4 times speedup. Why roughly? Because there is some cost for running threads and there is some cost at the end to make the final sum, okay? But really, if you will have 4 cores or more, and the code will be not pseudocode and real code, there's a chance that that idea and reality will really speed up. Some problems, like the problem you have here, is quite simple to be converted into a parallel algorithm. But in other cases, not so simple. And this is not the aim of the of my lecture, to teach you how to convert serial algorithms into parallel algorithms. Okay, this is totally different knowledge. But what is the aim of my lecture? To show you how to achieve such parallelism in Java. So I'm assuming that somehow you have in mind how to do some stuff in parallel, okay? But how to achieve it, how to run it in Java, I will try to show you during the next lecture, okay? And what is the concurrency? Okay, concurrency is an correct and efficient manage access to shared resources, which possibly could come from different clients simultaneously. Okay, so what is the problem? Just look at the operating system. In our modern operating system, you can run several programs in parallel, okay, in concurrent. So if somebody wants to access something, it could happen that the other process, in that sense, in operating system, will try to access the same data. And again, the same will happen in parallel computing. It will run several threads, and each of the threads, for some reason, want to access the same data. Okay, so let's look at this pseudocode. Okay, it is more Java pseudocode, okay, but still pseudocode. Okay, so we have a hash table. Okay, what is the hash table? Okay, so it could happen that two different programs, whatever we have there, will try to store something at the same moment. Okay, so the algorithm is as follows. Okay, we have insert, but we have to prevent other inserts and lookups at the moment we are changing the hash table. Okay, because if we will not prevent, you will get stupid results. Okay, maybe the other example from a reality. Okay, just assume that they are open. Okay, so you are selecting the place, and you are checking if the place is free. Okay, but it could will do exactly the same. And for example, the both of you labs place number 21. Okay, so the first guy is checking free, the second guy is checking free, and without some technique that will prevent with problems, as the results, you could both buy the ticket for the same place. Okay, so such problems exist everywhere where things could happen in parallel, and they could happen in parallel in our modern programs everywhere, since operating system is allowing us to run things at the same time. Okay? So we really need to prevent bad interleavings. Okay, so correctness is one of the problem you should take into consideration, but also you should take into consideration performance. Okay, because when you realize the concurrence in a stupid way, you could, for example, stop everybody of doing anything, okay, till you will finish. So the performance will be much slower because our clients are not able to do anything. So correctness is important, but also performance is important here. Okay. So what is the idea of threads? It's the idea of shared memory. Okay. So threads are connected with the idea of shared memory. In other words, threads allows you to play with the shared memory. Okay. Other tricks like processes or maybe workers in JavaScript does not allow to work with shared memory. Okay, so what is the problem? In a non-thread code, we have a call stack, okay, because we are calling some methods. So the idea is to put data on a on a stack, okay, we have one program counter, because we are only running one computer. We have some static fields of your elements and objects stored on the heap, okay? So this is the memory organization of computers you should be aware of from our courses. But here, each thread will have its own stack, its own program counter, okay? Therefore, if each stack has each thread has its own call stack, so there is no way to access another thread's local variables. But since we have a common heap, okay, we can access or share static fields and objects. So how do we communicate? How the communication between threads is realized? By storing, by reading and writing data. So into static fields and into objects. Okay. So one thread could change some attribute of an object and the other thread could read it. It's simple because we have the same memory. The memory is shared among different threads, but it causes problems. Okay. So threads have own unshared call stack and current statement. Okay, so PC program counter, its own local variables, but all objects are shared. Okay. Of course, not all objects are shared. Okay, but some of them are shared. So different threads that black circles, okay, could access the same data structures at the same moment. And this is dangerous because it could have a side effect. Okay? So we'll be talking a lot about the problem of accessing, but it is required, or it is one of the tricks. Okay, we have processes that is solved differently. That everything lives in a separate areas, okay, and only using some techniques of communication. We have, for example, some queue systems, some and other tricks used. Here, the trick is on one hand very simple. Each thread could access the same data. I'm not talking about local variables, but I'm talking about objects, okay, that they are stored on the heap. But unfortunately, it could be dangerous. Okay, so as I told you, this is not the only model, and some other models will be also discussed with you, not all of them, because this is a very broad area and under development from 60s really. So we have the idea of message passing, okay? So each thread, for example, could have, or whatever, its own collection of objects, and communication is by sending, receiving messages, okay? So it is, for example, that solution JavaScript for workers. Okay? I'm just close relative, okay, because all of the techniques use somewhere. Data flow, programmers write programs, okay, and we present them or we run them as a graph, okay. So result of one element is sent to the other element, okay. So the flow. So we build a graph of elements running one after the other. If some paths could be done in parallel, then it is possible, okay? And such system exists. Even a kind of such system I am building in one of the projects I am involved in. Other tricks that are now quite common, and even in Java, they are realized nowadays. It is a very common idea of functional programming that I will be not talking about with you because of the lack of time. Okay, you have just a limit of 7 lectures, but that trick is now becoming more and more popular. Okay, so it's a trick like apply function to every element of an array in parallel. Okay, in Java it is realized by multithreading. Okay, so something which is called map and reduce trick. Okay, and that trick becomes very popular nowadays because it allows to do simple things, but the problem of shared memory is hidden here. On the other hand, in Java, the data parallelism is realized by threads because threads are the primitive you have. Okay, but of course in Java, do even message passing is not a problem. And the system I'm developing and the idea of data flow has Java. It's not only Java, it's Python, Java, R, and other languages, but also Java is run in that style. So even in Java, you could achieve such techniques, but threading is the primitive. I mean, it was and it is the core of achieving and shared memory achieving results. Okay, so what are the problems or what are the needs we have to have? Okay, and then soon you will notice how we are realizing them in Java. Okay, so at first we need some methods, ways to create and run multiple things at once. Okay, and that things are called threads. Okay, we need ways of threads to share memory, and in languages like Java or C#, it is quite simple. Since all objects are accessed by references, so if you will share some reference to the same object among two threads, we solve the problem. And we need a way to coordinate or synchronize. This is the correct naming, okay? But maybe the word synchronization is not really meaning anything for you. I hope that after my second lecture, it will mean a lot to you, okay? So we need a trick that will force, for example, one thread to wait for another to finish, and other primitives that are needed to solve the problem of concurrency, okay? And we will be talking a lot about it during our today and the next lecture. So there are a lot of thread models, okay? We will be talking about Java threads from Sun Microsystems. Darius will probably talk with you about POSIX threads, which are popular in Linux system and in C language, okay? But different, they are quite similar tricks, but slightly different. Okay, so now we'll talk about Java, okay? So long introduction, but I wanted to, and I really added that introduction after my first lecture with your group because I have noticed that there was a lack of some basic knowledge. So let's look now in how those problems mentioned by me are solved here. Okay, so the code is simple, very simple. Okay, and one run it several times. Okay, so this is a loop that prints some data on screen. Okay, stupid idea, but working. That method called concurrent thread returns the representation of current thread. Okay, so it will show us on the screen the ID of the thread the code is run. Okay, And we have several options to achieve the same. These options are really connected with object-oriented ideas. Okay? So one of the tricks you can achieve multi-threading is to create a class that extends thread. Thread is the idea coming from the Java language. Okay, so we're extending the template, okay, called thread, and really the only and the most important element you have to work with is the method run. Okay, so the body or the code that will be run in different threads is that code. So the thread starts here and finishing here. Okay. So how to develop a thread? You have to create a class that extends thread class, and you have to call the method run. Not call, sorry. You have to write a method run. Okay. You have to code, not call. Never ever call run. Okay. It was wrong wording. So of course you can call anything what is possible to be called from here, even other methods of your own class. Okay, but still it is just a template. It's not yet run. Okay, so extend threads and how to run it? Very simple. You have to create objects, as many as threads you dream you want to run. Okay, so in the loop, I am creating threads, and on these objects, I'm calling the method start. Never ever call run directly because it will not create a new thread. Start, which is not existing here explicitly. Okay, it exists because it's inherited from thread. Create a thread object and call the method start. That's all. And suddenly, 4 times that code will be run in a different thread. And that's all. It works in parallel if you have a given number of CPUs. Okay, so new thread dot start, or new thread as an object, and object dot start. Okay, so how to run? So how many threads we will have here? 4, not 5, because we'll have 4 threads. The main thread, okay? Because if you run a code, you have 1 thread, because you need to have a thread to run anything. Okay, so if everything is run in a thread, but up till now, all your code was run in a single thread. Now, from that main, it's really called main thread, by the way. It's not just the wording in English; it's also its name. Okay, and from the main thread or other threads, you can run other thread. How to run a thread? Dot start. The run method finished. Okay, so the start creates some resource, and in some time, several milliseconds later, the run is, you will be at the end of that method. Okay, then the thread will finish. It's quite simple, I hope. The second option, very similar, but not based on extending thread, but based on implementing Runnable is an interface, and we have been talking about interfaces last week. Okay? So we can add capabilities of being a thread to any by implementing runnable and adding a method run. So again, you need to have a method that has no argument and doesn't return anything. Okay, it is an important statement. Okay, because later on I will show you how to inject some information, input information into a thread, and how to get information from the thread. You have to do it manually, but it's quite simple because it's an object, so it could have an attribute and use just attribute. The data we are sharing no arguments. Okay, so the trick is used because sometimes due to the fact that it is impossible to have multi-inheritance, we are using interfaces to solve that problems. Okay, the running of the code is very similar to the previous example, but not the same. So we have to create a thread and call start on it. But now we are creating not your own class, but you are using your class that is not thread, but is runnable. So you are injecting that object into the thread constructor. And now you will have a thread that has inside that run as the method. So tricks are very similar, and this is quite typical for Java, that in many cases you have both methods. Okay, so you could do something by dedicated classes, and you can do something but classes that implements a dedicated interfaces. Okay, which one is better? It's not the right question. You are selecting one of the method depending on the situation. Okay, so if you are doing a class from the scratch, you can use both methods. But if you have a class that has to, from some reason, extends other classes, so the only trick is to add implements to solve the problem. Okay, so maybe the thread due to chain of inheritance. And the third solution, the third option, which is really the second option, but run the so-called anonymous classes. And this is a quite common solution for doing simple things. Okay, in a Java style, I would say. Okay, so just I will come back to the previous slide. Okay, oh, the previous before. Okay, so okay, maybe that one. So how we are running a thread and putting here an object that implements runnable. Okay, and just look, it is exactly the same as the previous solution, but the difference is that we are not creating a name class with the run method. We are just writing in line. Okay, okay, I need a small thread. Okay, so I don't care about its name. So new runnable. So that's why it is called anonymous approach. So I'm creating an anonymous class that extends or implements runnable as the interface. So it has to have a run method. Okay. So it's exactly technically the same as these two slides, but shorter. Okay. If the code is short here, it is recommended solution, but sometimes such solution will be more readable. Okay. Just remember an important mark a remark that I want you to take into consideration, that you are not coding for you are not coding for a compiler, you are coding for me as the our human being. Okay, so readability is an important fact, but it's still the same as it was shown previously. Okay, so the same, but the other example. Why still the same? Because that's all about how to run a thread. Just two techniques or so it's simple, but you have to be aware how it is done. Okay, so again, what we've written in the example. So you have to create a class that extends a thread, one of the solution. Okay, create an object and call a method start. 3 steps. Or implement a runnable with the run method, create an object, create a thread based on this object, and call the start. Which one is better? I don't know. Depends on the situation. Okay, so because the first approach is exactly the same as the second one, so I was not showing it again, but it will happen on my slides. Okay, so some tricks, some methods that are available in the thread class, or some methods of manipulation of the current thread. Okay, so what we have here, we have the main, and we are reading the current thread. Okay, and what we can do to see the thread ideas. So its name is, but it's main thread. Okay, as I told you. And what the thread does, 5 times prints a number on the screen and sleeps. Thread.sleep is a method controlled with thread, but sleeps the current thread. What does it mean, sleep? It stops its working. How? Okay, I will explain soon. It is in milliseconds, so it means 1 second. Okay, and now the other example with threads. Okay, so I'm creating a class that implements runnable. Okay, I am running it in a constructor. What does it mean running? I don't know. I have to method. It will be on the next slide probably. Then sleeps for 3 seconds and goes further. Okay, and here the run method. So each thread that will be started here, now only one, will do like here, because this is the beginning of the real thread and this is the end of the thread, is inside a run method. Everything, all the life of thread is inside. When you call start on the thread object, it really soon calls the run, and when the run finishes, the thread is dead. How to stop the thread? Stop the method run. There's no other way nowadays to stop a thread than somehow force run to go further. Okay, we'll come back to that problem later. So it prints the same on the screen and waits 1 second. Okay, so if I run it, that will be the result. 5, 4, 3 coming from here. Exit my thread. Why exit my thread? Because it waits 3 seconds. So now we'll have 2 threads. That one that prints that numbers, okay, and that one that is waiting here. So things will happen in parallel. The other example, more realistic but larger one, we will have different classes and we'll call them. Okay, so I'm creating a class that forever, okay, it will never finish, print stupid, ever stupid thing on the screen. Okay, I am creating the first object, the second object of the second type, starting the first thread. This is the first thread, starting the second. How Java works, okay? There's one exception to the rule. I'm in daemon thread, but okay, it will be introduced by me slightly later, but without that daemon stuff, the Java finishes its running when all threads are finished. All threads are finished. So when you start to play soon with threads and your code is not finishing, so the Java is not stopping running, it mostly means that one of the threads you have started is not finished. Okay, that code is an example because this is an infinite loop. So it's stupid deductive code. So that code wants to point your attention to the fact that the Java finishes its running, not when the main finishes, when all threads finishes. Okay, main is one of the main thread. Okay? It's the main thread by so up till now used by me today. The understanding was simple. When main finishes, the code finished. But now it's a more general statement. It's more general. All threads has to finish the running Java. Okay, so different things will happen on the screen. Slightly more examples. And these examples are quite important to understand because I will try to show you now how to pass some values to the thread. Okay, because it's a simple trick. Arguments, data to the thread. Constructor is a trick. Okay, so let's look at the trick. So we have a class thread, of course. It has a state. Okay, and the state, that attribute, is set up by the constructor. And since the run is a non-static to the name, okay, so how to pass some data into the thread? It's not the only way, okay, but the best way is to use constructors. Okay, so pass here some objects, references to objects, store them down, you have an access to it. Okay, so assume that you have a thread that does some calculation, so it needs some arguments, the constructor of your own class. Okay, so this is the solution to the trick, and I will require to use that later on the lab, but the lab is still behind you. Okay, so stupid things on the screen. Okay, so few ideas how it really works. So the idea about thread scheduling. Okay, so we have a set of threads. Okay, because you as a coder could create threads and threads and threads and threads. How many you wish. Okay, because there are some technical limits, but theoretically it is unlimited. Okay, so we are creating a thread and then calling a method called start on this thread. Okay, and what does really start do? Start creates some resources, some data set, and puts that objects in something that is called ready queue of threads. So we have a queuing system, and threads are stored there. And each thread is taken from the queue one by one, because it's a queuing system, okay, and run. So at a given amount of time, in a given millisecond of time, only a limited number of threads are run. In that sense that they have an access to CPU. The number is equal to the number of cores you have inside the computer. Okay, so in the case of a one core computer, only one thread is really running, but from the perspective, a lot of threads could be run because they are inside the ready queue. Okay, and after a slot of time, which is around 20 milliseconds, so very short time, the thread is so the code is taken off from the CPU, thrown back to the queue, and the next element taken from the queue. Okay. So since the time is quite short, 20 milliseconds, so looking for the human perspective, all threads, okay, there are exceptions because threads could be sleep and other tricks. I will show on the next slide. But from the human perspective, all threads, all running threads are running, so have an access to CPU. But technically speaking, this is limited to the number of CPUs. Okay. What else could happen? Threads could be blocked. Very often you will block threads for some reason. There are some blocking instructions that blocks the thread. For example, was a blocking instruction. We have also and also some operation on devices are blocking instructions. External watch resources are very slow compared to the CPU. So not to stop other threads running, if the block instruction is called, the thread is going to the blocked queue. Okay, so we have two queues, the ready queue, running queue, and the blocked queue. Okay. So they are waiting operation, notifying, sleeping, synchronization section, and we'll talk about all this stuff. Okay, so I have introduced threading. I have shown you how really simple it is to run in Java, but I will talk about more and more sophisticated. Okay, so if the blocking finished to some reason, for example, sleep is a time. Okay, so when that thread is thrown back to the ready queue, and that's all. Simple idea. Put data in a queue, get one by one, run them from time to time in a separate room, waiting room. Okay, it's like our labs. Okay, you are coming to the lab, you are stored in a waiting room, and I'm picking you one by one because I'm in a single processor. Okay, if there will be two teachers, two things could happen in red in parallel, okay? So imagine that if we have two CPUs, four CPUs, it will mean that 4, 2, 8, 16, whatever CPUs you have, that amount of threads could be run in a real parallel stuff. But even on a one processor computer, you could have multi-threads, number of threads, okay? Of course, they will use only one CPU. But when you have more than one, it is a natural way of scaling the system, okay? So all the time, you could call the get state and check the state of the thread. But on the other hand, the thread is running only when it has an access to CPU, okay? Because when it's here and here, it has no access. So the PC counter is not moving, okay? So I'm calling the start, okay? So it's in the state so-called runnable. It waits for the CPU. Okay, this is not runnable interface, it's the name of the state. Then if wait, sleep, whatever is called, it is in a blocked state, and then come back to runnable. Okay. We don't see that these two states because only when the thread is in that red color, it has an access to CPU, it could do anything. Okay, so you can check the state. So it's simpler view, but because some things are unseen. If the thread has no access to CPU, it is not doing nothing. So this is running, okay? And this is so-called alive, runnable and blocked. And when the run finishes, the thread is dead. Okay, so new, runnable or block, runnable, block, or dead. Of course, runnable is strictly speaking also two states. You have CPU, you wait for CPU, but waiting is unnoticeable from the code point of view because when you wait for the CPU, nothing could be printed on the screen because you have no access to CPU. So it's a hidden state. Okay. Java maps threads on the operating system threads. Okay, so the same code written in Java run slightly differently depending on the operating system you have. So never ever depend on ideas as time slicing priorities. Okay, they exist now. I can notice that there's time slicing. I told you around 20 milliseconds, but the value and how it's realized is the task for operating system. That's why also Darius will come back to that problem because one of the main problems of all operating systems is scheduling of processes and threads. And we have also the something which is called the priority, and you can set up the priority of the thread, even in Java. But how the priorities are realized in practice depends on your operating system. Okay, so really the idea is obvious. When the priority is higher, something should have more access to CPU more often, but it is twice often or just 10% more often. Depends on a virtual machine and operating system. Okay, so do not count on scheduling and priorities for algorithm correctness. Okay, you should be aware that such things happen, but do not take them the exact values into consideration. Okay, because it is operating system and Java implementation could be done differently. Okay, so now let's look in other methods that are available inside the thread object. Okay, so if you are a class extending thread This is your method. If you're a class implementing thread, you can access thread by the method called getCurrentThread, okay, and then you have access to it. Yield. Yield is a method that throws you out. I will come back to the previous slide. Okay, so the code runs like that. When it stops to run, one of the idea is to have a time slice. Okay, so there is a given amount of time that the thread stays inside the CPU. But you could all the time call yield method that throw out you from the running to the queue. Okay, so it's like a method. Does somebody else wants a CPU? Okay, if you are the only thread inside your code, or if other threads are blocked, running of yields does nothing. But if there is any other code running, waiting for the CPU, yield will allow the other threads to run. In ancient time of Windows 3.0, okay, so the times when in operating systems that were before 386 computer architecture of Intel, okay, like Windows 3.0, there was no way to throw out the thread from the CPU. And it has to be done by the thread. So the trick was call yield as often as possible. Now you could do it for strange or unusual purposes, okay? But it is not required, but still yield exists, okay? So when you call yield, your code is thrown out from CPU, and if any other thread is available, okay, the CPU is given to him. If not, the CPU is still for you, okay? So you are very polite thread. Maybe I'm not so important. Maybe you want CPU, maybe you want CPU. If not, okay, I'm still. Maybe you want to talk, maybe you want to talk, okay? You don't want to talk, I will talk more, okay? This is that idea of sharing some elements, okay? So let's look at the example. And you have yield here in all threads, okay? Because we have two threads with the yield. So the results will be thread 1, thread 2, thread 1, thread 2, thread 1, thread 2, one by one. Without yield, there will be several thread 2, several thread 1. Why? Because without yield, the loop is running for 20 milliseconds, so probably 10, 100 times some printouts. But with yield, one by one thread will be run. Okay? So notice the alternation of output, one by one. Okay, I have mentioned the daemon. Okay. Generally, all threads are non-daemon threads. So for example, the main is non-daemon thread. And you can all the time change, let's say, normal thread to daemon thread. There is a method called set daemon. What is the difference between a daemon thread and non-daemon thread? This is the difference connected with finishing the execution of the application. Okay, so application finishes when all non-daemon threads finishes. Okay, so if a daemon thread is running and the main thread finishes, application finishes. Okay, So when only daemon threads stay alive, they are killed and virtual machine exits. Okay, sorry. The next element of the thread set of methods, join. Okay, so this is the example of the code. Join. Join is the simplest method of waiting others to finish. Okay, so maybe I will draw something. Okay, maybe we don't have a whiteboard here, but we have a pen. Okay, so this is main. Okay, so I will write M, and this is T1. Okay, so what is the idea? M goes, then we have start. Okay, start causes T1 to start, but also still main is run. But when we have join, okay, then main is stopped till T1 finishes, okay, and then main goes further. So main joins T1. It means that main thread is in a blocking state till T1 finishes. Very simple method of synchronization. One of the, but very often it is enough, but not always, of course. So we wait until we, as the main thread, or the thread that calls that my thread, okay, the T1 thread, waits until the T1 thread finishes. Okay, so join causes that the code here will be, it is a blocking instruction, will be blocked, okay, will be stopped, blocked in the sense not going further till that T1 finishes. So if I am joining you, it means I'm going to bed for a sleep till you will finish. Okay, so when you will finish, I'm back on the stage, okay, and then I could do something more. So join is a blocking instruction causing waiting of the current thread till that thread which I'm joining to finishes. So technically speaking, it causes that I am the main thread, the thread we are running, to go in a blocked state. Okay, so just remember that. Okay, you should print that slide and put it in the front of you. Okay, maybe I will write more red element calls. Okay, so I have 4 elements running in parallel. So when a join is called here, I'm going to the blocked state till the thread that I join to finishes. So till it will go to the dead state. Okay, so that's why these states are quite important to understand what's going on. The other trick that was already shown by me is the sleep. Sleep causes the current thread to go into the block state for a given period of time. The thread does not lose ownership of any monitors. Okay, that statement is probably hard to be understood now, but I will talk about monitors next week. Okay, but what is important that sleep And that's why when we have examples with slip, we have some examples in the past, maybe not here. Okay, so I will. Okay, it was far away. Okay, you can notice that we have a try and catch section. So slip blocks me. Okay, I have run sleep for a second. I was silent for a second. Okay, so this is the sleep working. Okay, but it could be interrupted somehow. Okay, I will show you how. So there is a chance that you will not have to wait till the end of sleep, and that information that you were interrupted is noticeable by the exception that is thrown inside sleep. Okay, so the example of join. So we have a thread, we have the main that calls the thread, the main thread start. The thread stuff is done with okay, sleep could be broken by interruption. Okay, what does it mean and how to achieve it will be shown soon. Okay, so as I told you, threads in Java are based on shared data. Okay, so whatever data is inside the memory you can access, but of course to access you need to have a reference to it. Okay, so it's simple, but okay, you have to pass the reference to the child thread. Okay, the best idea is to use constructor. Okay, and retain the instance as a data member. I was showing that example, but once again, because again, I have noticed last year that a lot of you have problems with that. Okay, so the idea is simple, could have any data, not just a string, any data. Okay, and you can pass it, start as an attribute, and access it anywhere. Okay, so just notice that now I'm not only accessing the data, but I'm also changing these data. Okay, still the data are changed, and these changes are noticeable outside. Okay, so I have the second that decreases the same data. Okay, so I have here increase, and I have here decrease. Okay, so they are fighting each other, and it could cause problems. But because if the two things are done in parallel, it could be dangerous. Okay, now we have simple data as an integer, but assume that we have more sophisticated data structure. So what will happen if suddenly the first thread is stopped because of the end of the time slice, and it has not yet finished the decreasing. Okay, just imagine that integer is a 4 byte. So what will happen if we'll decrease only the lower byte, and then we are thrown out from CPU because it will cost. Okay, it will not happen with a simple type as integer, but with more sophisticated types, it is dangerous. That's why now I'm switching to the most sophisticated element of the multi-thread programming, so the idea of synchronization. Okay, I will just only introduce it today because it will be the main topic of the next lecture. So how we are doing synchronization in Java. We have a method called we have a reserved word called synchronize, okay, and we can synchronize methods or really synchronize any object, because synchronization and method is a trick that synchronizes the whole object. Okay, and we have methods from the thread class like wait, notify, and notify all. And all these 5 elements allows you to solve any problem. There are different high-level tricks to play with synchronization in different languages. In Java, this is the core. Of course, you could have, for example, semaphores, but semaphores in Java are based on these basic methods. Okay, so we'll talk about how to implement semaphores in Java also next lecture. Okay, but let me introduce the problem of synchronization and how it is solved here in Java. The idea of synchronization in Java is based on so-called monitor. Okay. This is the concept object has a monitor. Okay, so whenever you create an object, also something that is called monitor is assigned. And it plays a role of a guard. Okay, strong guy that watches and blocks of code, okay, are secured by it. Okay, and you are using the next important name called critical section. Critical section is a piece of code that you want to secure, or technically only one thread could enter the okay. Very often there's a need to create so-called critical section. Okay, in Java it is done by monitors. So when you have something which is called critical section, and this is achieved in Java by synchronize word, magic word, synchronize statement, it causes that only one thread is inside. If any other threads will want to access the same critical section, not other sections, it will be stopped. So the trick is that when we are entering a critical section, a thread takes the ownership over a corresponding monitor, okay, until it finishes. No other threads are able to acquire an ownership. So other threads has to wait. Okay, so we have guards called monitors that guards pieces of code. Okay, so only one thread can own a specific monitor. Only one thread can own a specific monitor. So if a thread A tries to enter a block under a monitor, and any other different thread wants to enter the same block, okay, it has to wait till the monitor is released. So they are working like locks, okay, or they are connected to locks. You will see locks as a trick used in C++, for example. The locks are the primitive used in C++ to solve the problem of synchronization. In Java, the trick is called monitors, and it's slightly different, but it's okay. We have different tricks, different methods to solve similar problems. Okay, so when a thread leaves the critical section, the monitor is automatic. If the thread wants to access, wait till the monitor is released, it goes to that funny blocked state. Okay, so the state I was showing you previously. Okay, How it is achieved in Java? Very simple. We have a magic word called synchronize, okay? And the most common situation is to put that word before the method. So coming back to the incrementation and decrementation example, this is the correct code, okay? Because that code causes that if somebody will want to increase, decrease, or get the value during increasing and decreasing will be stopped. So if you put a word synchronize before the method, so anything inside the method is a critical section. And if anybody will want to call it, he or she has to take a monitor, and the monitor is connected with the object, okay? So all three elements will have to wait for each other, okay? So if you have, this is of course very simple case when we have only one element to be synchronized, okay? That's C. If you have 2 elements, 3 elements, okay? Sometimes if they are independent, you can multiply that solution, but if there are some connections among them, you have to use your mind, okay? Synchronization, threads, and synchronization requires thinking. Okay, this is not a stuff that could be done automatically. You have to think in a strange way as a computer, right? So the synchronize keyword on a method means that if this is already locked anywhere by any other thread, we need to wait till this is unlocked before entering the method. So if in a given moment of time, 1,000 of threads will call increment, decrement, or value on the same object, okay? Because each object has its own monitor. So you can call increment on object 1, and the other could call increment the same time on object 2, okay? But remember, it is connected with objects, okay? Not with methods, but methods inside objects. The next important state, okay? The other trick that could be used is to synchronize blocks. Really, that stuff is the same like that, but you are synchronizing everything, okay? So this is just a sub trick to that main trick, okay? So the argument of synchronize is here it means the object inside those increment is running. Here means me, my object, but could be any object, okay? Argument is an object, and you are synchronizing the block, okay? So different methods could get inside at name, but that piece of code, that small element of the code, okay, that I will try to mark and write, is that so-called critical section. And here, only one thread could be inside. Okay, other threads could do other stuff, but if another thread will go here, he will be or she will be stopped till that critical section is finished. Okay, so the monitor is taken, one thread is doing, the other has to wait. So this is a low-level primitive that allows you to deal with synchronization, okay? So when synchronizing is a block, key for the locking should be supplied, okay? And most common is to use this, but it could be any object, okay? So if you want to have global blocking, you could have a global object and use it to prevent others to do things at the same time, okay? So, of course, synchronization is not always needed, but if you are accessing the same data, you have to, okay? And this is all for today. Of course, this is very sophisticated, and we'll come back to the problem of synchronization during the next lecture, of course. And I will discuss in more details what wait and other things mean. So thank you very much for your attention. Short break, and see you soon on the lab. Okay? Bye-bye.